This lesson is titled Estimate Products of Whole Numbers and Decimals. So last chapter, chapter 5, was all about adding and subtracting decimals. And this chapter is going to be about multiplying some decimals. So today's lesson, you can tell, is an estimating lesson. That means that we're not actually going to be multiplying and finding the exact answer. Instead, we're just going to be finding an estimate of the answer. All right. So, how is multiplying and dividing decimals similar to multiplying and dividing whole numbers? That's our question. And I can tell you that it's pretty much the same. Just like, remember when we added and we subtracted decimals, how we notice that a lot of what we're doing is the same, except you just have to have a decimal point in your answer. But the adding was the same, the subtracting was the same. Same thing goes for today. Whenever we're going to be doing multiplying or dividing, we kind of deal with the decimal either at the very beginning of the problem, and then we do our division or our multiplying, or we deal with our decimal at the end of the problem after we're finished, and we kind of ignore it at the beginning. So both ways, it's very similar to multiplying and dividing whole numbers, except you just have to deal with that decimal point. You're either going to do that at the beginning of the problem or at the end of the problem. So you're going to see how similar it is. Okay, so here's our problem of the day. If you have a whiteboard, you could solve it on there. If you don't, just use a little corner of your notes. It says Bren has 4 dimes, 2 quarters, and 3 nickels. She spends 35 cents. So how much does she have now? So this is, first you have to figure out how much all of that money equals. Then you're going to subtract 35 cents from that, because that's how much she spends. So we're practicing something we remember from chapter 5, which was subtracting decimals. Okay, so work that out. Then we'll talk about it. So 4 dimes would be how much? Nolan, how much?
40 cents.
40 cents. How much would 2 quarters be, Hamza?
50.
50 cents. And 3 nickels, Amelia? 15 cents. So we're going to add all of that together. So that would be $1.05. So that's how much she had. And then she spent 35 cents. So we're going to subtract that. So then I'm going to borrow from my whole number.
Oh, I did it wrong.
So my answer should be 70 cents. So she has 70 cents left over. Give me a thumbs up if you got that one. Good. Good. Okay. Because she had $1.05.
4 dimes.
4 dimes. Yeah. They did them in a different order. They weren't in the least to greatest or anything. They were all mixed up. All right, now you know. As long as you know what you did, if you didn't get it.
I can't find my pencil for the Great Pencil Challenge, and I'm sitting over there with him.
All right, so the question for today on our investigate slide is, how do you estimate products of whole numbers and decimals? So here's a few examples. In your notes, so this part's for your notes that you already have gotten out. We're on chapter 6, lesson 1. It's called Estimate Products of Whole Numbers and Decimals. So our title of our lesson tells us that we're going to be estimating. That's not an exact answer. We're going to be probably rounding something and then multiplying it. And then products tell us we're going to multiply, because the product is an answer to a multiplication question. And then we're going to be using whole numbers, which means it's a number without a decimal point. And then we're going to be multiplying that with a decimal. So we're going to be multiplying 2 numbers, one that's with one's a decimal and one is not. So here's our first example. Here's what we mean by all of that. If I have 94 cents and I want to multiply that by 4. So for instance, let's say I go to the grocery store and I want to buy 4 cans of corn and they are 94 cents each. And I want to make sure I have enough money. Instead of doing in my head 94 cents plus 94 cents plus 94 cents plus 94 cents, I could do that. Or I could do 94 cents times 4. Or I could round that number. So if I'm rounding my decimal, which is 94 cents, to the nearest whole number, that means my choices would be 0 or 1. because 94 cents is less than 1, right? Because there's no whole number, there's no number in the ones place. So what would I round 94 cents to? What would I round it to?
You would round it to $1.
I'd round it to $1. So my estimate would be $1 times 4. So then my final answer would be about $4. It is an easy one, but we're going to be doing some more. That was just the first example. So basically, see, I drew the little number line here. 94 cents is going to be pretty close to the whole number. It's even closer to that. You're right. All right, here's another example. Let's see if this one's a little harder for you. $3.92. They're not all going to be money, but the first few here are. Times 5. So the basic thing that we have to think about is what are our choices when we're rounding. So it's either that this number is going to stay the same or that number is going to bump up by 1. That's what you need to think about. Can you sit right here?
Yes.
Thank you. So basically, your choices on our number line are going to be either 3 or 4. So think of, we're just going to look at the whole number first, and either the whole number is going to stay that, or it's going to bump up by 1 if it's closer to the next number. So that means I have $3, 3 whole dollars, and then I have 92 cents of another dollar. So $3.92 is going to be pretty close over here, right? If $3.50 is here in the middle, like $3.50, $3.92 is way closer to the 4 than it is to the 3, right? So that means we would round it up to $4. And if we multiply that by 5, our final answer would be $20. Okay? Nod your head if so far it makes sense. We are rounding, we're either leaving the whole number what it is, because maybe if this were like $3.11, we would leave it as $3, right? Because it's way closer to $3 than it is to $4. So let's think of it like this. If it's 50 or more, yeah, if it's on the other side of the 50, like the greater side of 50 cents or of 50, then it's going to go up. If it's under that, it's going to go down, stay the same. All right, let's try another one. This one without money. But still, it's the same thing. But I just want to show you that it's not always going to be with money.
Oh, that could be
So
the 70.
this one has double digits there at the beginning. So this number goes up to the tens place. So if you're going to round it, you always have to round it to the highest digit that you see. So in this case, it's a 6 that's in the tens place. So listen. Instead of, Aiden, please stop talking. Just listen. If you have something you want to share with us, you have to raise your hand. Otherwise, nobody's listening. And then they're hearing me and you at the same time, kind of competing with their voices. So if we have $68, we're going to round, since that is that's the tens place, so we're going to round to the nearest tens place. So that means if I look to the right, since the next number next to it is an 8 next to the 6, then that means I'm going to bump up the 6 to a 7, and I'm going to make it 70 times 4. Keep in mind, because some people might say 69, maybe you should bump it to 69. Is 69 something I can easily multiply in my head? Probably not. So the whole point of estimating is so that you could really easily multiply something in your head. So 68, I'm not going to change it to 69. I'm going to bump it up to 70. So you're either trying to get a number to the ones place, or you're trying to get a number bumped to the tens place with a 0 after it. So a power of 10. Anytime, because we know how to multiply powers of 10. We've done this before. So now all we have to do is multiply the whole numbers, like 4 and 7, which makes 28. And then you just add that 0 on the end. So then your final answer is 280. About 280. Okay? So the point is, and I know that some people are going to round that to 69, and then they're going to do 69 times 4. That is also an estimate, but what we're trying to do, we're trying to stick to mental math. We're trying to stick to the math that we can do in our heads without trying to write anything out. Anthony.
So, did you round to 68?
I rounded the 68, and I kind of ignore the decimals because we're trying to estimate in our heads. And so it's really hard to multiply decimals in your head and all that. So we're trying to get rid of the decimals and just use the whole numbers. Jameson. Do you mean like if you got rid of this and you made that 69?
If we got rid of the decimal and then we tried to multiply would we get the same?
Like this?
Yeah.
Let's see what we get. It's close. But this way, I didn't really have to do I didn't have to actually work anything out. It was all mentally. So, because it's an estimate, it's better to do it like this where you could do it in your head. Because it's all about how much can you do without, like if you have a shopping cart at the store and you're trying to buy stuff, and you have no paper, and you have no calculator, and you're trying to do it in your head, it's going to be easier to round it up and then use a multiple of 10 to multiply with. Okay, let's try another one. This one's 20 and 1/10 times 9. How would you change this one? What would you do here, Hamza? I would make the 20 and 1/10 just a 20 and multiply that by 9, right? Because 20 and 1/10, remember how I told you if you're looking on a number line, this time my choices are 20 and 21, but 20 and 1/10 is way over here. Because the number after the decimal leads you way closer to the 20 than it does to the 21. So you'd leave it as a 20. 9 times 2 is 18, and then you add the 0 on the end, so you get 180. Nod your head if it makes sense so far. Okay, good. I like to do just a little checks in between to make sure. Let's see. So, I want you to draw this really quick in your notes. I want you to draw a 10 and an 11. So you have a number line with 10 at the beginning and 11 at the end. Then we're going to put 10 and 5/10 here in the center because that would be halfway in between. And then we're going to fill it up with all the other ones in between. So you can fill it in if you want to. I don't have a lot of space, but 10 and 1/10, 10 and 2/10, 10 and 3/10, 10 and 4/10, and then you have 10 and 5/10, 10 and 6/10, 10 and 7/10, 10 and 8/10, 10 and 9/10, and then 10 and 10/10 would really be 11, right? Because you would regroup and bump that over. So if I have a number like 10 and 2/10, I want you to mark that on your number line. Would you round 10 and 2/10 up to 11, or would you round it down to 10? Down to 10, right? Because it's closer. So we're going to just write this into our notes that we would round that down to 10. What about 10 and 7/10? That would be rounded up to 11, right, Cameron? Because that one's closer to the 11. So in your head, you don't have to draw a number line every single time you're doing one of these problems, but in your head you can be kind of imagining what the number line is. Everybody knows why I came up with the 10 and the 11, right? The 10 is the number that is here at the beginning of the number, and 11 would be what it would be bumped up to.
Both in between.
So, well, 10 is the lowest it would be, and 11 is the highest it would be.
Those are the numbers that those are in between.
Yes, these numbers
Are going to be in between.
are in between 10 and 11. And when we're looking at whole numbers, you're right. Okay? So, as we're working through these, if I gave you $16.87, what would you round that to? If you were rounding to the nearest whole number, what would you round it to?
$13.
Wait, let me say it again. $16.87. $17. What about $15.42? Carnpreet. $15. So you guys are doing a good job thinking of the cents, right? So you're thinking of what's the decimal point, what's after the decimal point, and is that going to cause it to round down or round up? That's what you're going to be thinking about. All right, let's look at your math page. Oops, not that one, this one. So example number 1 says that Mrs. James buys about 15 and 8/10 gallons of gas each week for her car. About how many gallons will she buy in 5 weeks? So 15 and 8/10 if I were rounding it, which number would I round it to? So my choices would be 15, which is where it is, like with the whole number that started there, or 16, which would be bumping it up. What would you do with it?
I would bump it up to 16.
Bump it up to 16 because 15 and 8/10 is going to be about right there. So we're going to bump that number up to 16. Because the number was 15 and 8/10. So 15 and 5/10 is halfway, right, Anthony? 15 and 5/10 would be like about right here. 15 and 5/10. And so anything above that is closer to the 16.
Actually, 15 and 5/10, so would it be?
That one could go either way, really. Usually you round it up, though. Yeah. 5 or more, you're going to round it up. So you're going to, but I mean, technically it's about the same distance, but usually you round it up. So in this case, Angelina was right. You'd bump it to 16, and then you do the math there. That would be 30, 80. So 15 and 5/10 times 5 is about 80. So she buys about 80 gallons of gas in 5 weeks. Now, because this is estimation, if you made that number 15 times 8 or times 5, it wouldn't be incorrect because it's an estimate, and estimates are just a number that's close. But our estimate of 80 is going to be way closer to the actual answer than you would get if you did 15 times 5. Okay? Let's look at the next example. Oh, this one is showing you that you could check using repeated addition. The reason why they're saying repeated addition and not multiplication is because you haven't actually learned how to multiply decimals yet. And there's, it's unlike, it's a little different than when you add or subtract because you don't just drop the decimal down into the answer. Instead, you have to do some different things to get your decimal in the right place. So because you haven't learned that yet, they're telling you to use repeated addition. So if you wanted to use 16 plus 16 plus 16 plus 16, that would equal 80. Or if you want to do this, and add all that up, 15 and 8/10 5 times to get what the actual answer is, you could check that. 79, he says 79. I would tend to agree. It's probably really close to 80.
It is 79, because, I mean, if you do 8 times 5 would be 0, and then carry the 4, and then 5 times 5 would be
25.
and then add the 9, and then it would end in a 9, and then the 2, and then...
Yep, it's 79. I knew it would be really close. So because 79 is really close to 80, the answer is reasonable. Now, sometimes all you have to do is think about it. 10 times 5 would be 50, right? 20 times 5 would be 100. So if your answer is somewhere between 50 and 100, it's going to be the right answer. So you see how I came up with that? We did 16. 16 is in between 10 and 20. So my low estimate would be 10 times 5. My high estimate is 20 times 5. And so if your answer actually falls within the range of the high and the low, then it's probably the right answer. That's another good way that you could check really quick. Example number 2. A worker loads 16 packages onto a truck. Each package weighs 58 and 5/10 pounds. About how many pounds are loaded onto the truck? So the product of 58 and 5/10 and 16. So in this case, they're asking you to use compatible numbers, which is another, remember how we've done this before? We just didn't use decimals, but we've done compatible numbers before. It's where you choose numbers that are something that you could easily multiply in your head, which is what we've been talking about. So if you change 58 and 5/10, what do you think you would change it to? Something that you could easily multiply in your head. What do you think, Concrete?
60.
60. He's making sure that that double digit number there ends in a 0, so it's easy to multiply. And then they change 16 to 20. Now remember, every time you change a number, you get a little farther from the actual answer. But this would be a good way to be able to multiply in your head. Now if you did 60 times 16, you're going to get closer to the actual answer. So on your assignment today, it might tell you to use compatible numbers, or it might tell you to round or whatever to estimate. Use whichever way you'd like to use, because this is an estimating lesson and I want it to be something that makes sense to you. When you're multiplying, but if I change both numbers, like what they're asking me to do here, I've changed the 58 and 5/10 up to 60, and then I've changed 16 to 20. So obviously if I leave one of those numbers alone, it's going to be closer. When you actually multiply it and find 58 and 5/10 times 16, it's going to be closer. Oh yeah, for sure. So this one would be 6 times 2 is 12. And then you add 2 zeros to the end is about 1,200. If you did it this way and you only changed the one number, the decimal, and you left the whole number alone, it is harder, but your answer is closer. So it depends on what works better for you. Some people don't like to switch on and off ways. See how we have 960? So your actual answer is going to be closer to 960. It's going to be closer to 960. You're right. So this number is 240 lower than this one. So your actual answer, though, is going to be closer to 960 than to 1,200. So if you're looking for a more accurate estimate, like if you're at the store and you only have a certain amount of money to spend and you want to make sure you don't go over, you're probably going to want to use a closer estimate like we did here. True, if you rounded down a little bit, if you had only a certain amount of money, that's a good idea. So it would be about, we could say 1,200, or we could say 960. See, I would take either one of those answers for the assignment tomorrow. It does want you to do 1,200 on this one, because you're using compatible numbers. So that's why they changed both numbers to numbers that ended in 0 to make them compatible with each other. That's why they did that. All right, but the estimate's a little further off. All right, so I want you to try the 4 guided practice questions. And when you're finished, I want you to make sure you double check them with a neighbor. And if you've checked them, then I'm going to give you your time to work here. Okay? So once you make sure you check it before you start independent practice. And then if you have a question for me, make sure you raise your hand and I can help you.